Hi, I'm Nicholas Moretti, Senior Program Manager for Azure Space for Microsoft Australia. Today, I'm delighted to be joined by Tat-Jun, or TJ, from the Australian Institute for Machine Learning. Azure Space reflects Microsoft's strategy for cloud-powered innovation on and off the planet. We're working with partners to showcase what can be done when you have access to cloud computing, space technology, and global connectivity. And as part of that, we're working with the Australian Institute for Machine Learning. TJ, can you tell us a little bit about the Institute and your vision for our collaboration?
Sure, Nick. The Australian Institute for Machine Learning, or AIML, has significant strengths in AI research, particularly in areas of machine learning, computer vision, and natural language processing. AIML's vision is to be a global leader in fundamental research, as well as in the translation of those research outcomes to commercial activities. Our researchers publish regularly at the top academic venues in AI, as well as conducting lots of valuable commercial research. My team is currently part funded by SmartSat CRC, and we focus on AI and ML and computer vision for space problems.
Yeah, sure. So how can artificial intelligence and machine learning be applied for space?
In my opinion, there are two main ways in which AI can contribute to space. Number one, with more and more space platforms or satellites being sent to orbit, we're getting lots and lots of data from space. Processing this data with manual effort is no longer possible, and that's where AI can contribute significantly by helping to extract meaningful insights from space data automatically. The second way in which AI can contribute to space is by helping to automate a lot of the operations in space. This includes satellite operations as well as eventually planetary activities involving autonomous rovers.
We're currently exploring a project together using Azure Orbital Emulator, or AOE. AOE lets you understand how an application may perform in space without ever needing to launch a satellite. Can you explain to me a little bit that project and how you plan to use AOE?
I think AOE is a fantastic platform for developing algorithms for space applications. The specific one that we're currently investigating is space-based swarm intelligence. As space utilization transitions from one that uses a single complex satellite to support a monolithic mission to one where a swarm of cheaper, simpler satellites are used to support a single mission, space professionals are hoping to see space missions that are more resilient and flexible. For example, in the distributed approach, when a single member of that satellite network is damaged, the other satellites in the same network can hopefully fill in the gap and the mission can still proceed as usual. Getting to a stage where we have a swarm of satellites in space where we can test our algorithms is still a number of years away. But with a platform like AOE, we can algorithm developers, particularly AI researchers, can immediately test their algorithms without needing that space-based platforms ready. So, Nick, this is not the first time we'll be working together. We first met when you were studying at Adelaide University. Can you tell us a bit more about how you started off as a student and now ending up as a senior program manager at Microsoft?
You're correct, TJ. I studied my undergraduate here at the University of Adelaide. That's where I first got exposed to the space industry. I worked on a project called SUSAT, which was a satellite design and build project led by the University of Adelaide. And that's where we first crossed paths. We then continued to work together on a number of space R&D projects while I was working at Innovore Technologies, but I moved across to Sydney for a few years to work in management consulting, focusing on data, AI, and cloud engineering. The opportunity at Microsoft presented itself, and I thought it was a really unique combination of my experience in the space industry, but also in cloud computing. But Adelaide is a very different city to the city that I left a few years ago. Lot 14 is the home of the Australian Space Agency and the national focal point of the Australian space industry. And Azure Space is really excited to be based at Lot 14 and contributing to that ecosystem.
You're definitely right, Nick. In the past few years, there have been significant changes in South Australia. Lot 14 is a visible representation of that change. As an educator at the University of Adelaide, I think that the space sector is special because the skills that it requires is quite diverse. We mentioned earlier, for example, agricultural applications, environmental monitoring, all the way to space mining. These activities will require skills from people who study computer science, engineering, but also people who study biology and mining, environment as well. In order to reap the benefits of the growth in the sector, it is vital for the next generation to take up the STEM skills required.
So we've talked a lot about how your research impacts the space industry directly, but what are the impacts beyond the space industry?
As we know, space has a large number of downstream applications. For example, data acquired from satellite platforms have been used to inform environmental monitoring activities as well as agricultural activities. Within AIML, we've had a previous project where we use space-derived imagery to assess the quality of pastoral regions. And this helps environmental agencies monitor the health of the land better to ensure, continued prosperity of our agricultural regions. Other applications include economic forecasting. For example, counting cars from space, especially at parking areas of shopping malls, for example, have been established as a good indicator of economic health.
I think a lot of people sort of don't realise that they interact with space infrastructure multiple times a day. So GPS affects people's navigation, it affects ATMs. There's even simple things like global communications and being able to chat with people in remote areas.
The mining industry in Australia also is heavily dependent on space technology. You mentioned GPS and communications previously, but a lot of the vehicles used in mining, for example, are now controlled autonomously, and space technology, particularly GPS, features heavily in that aspect of the operations. In the Institute, we're not just looking downwards or performing Earth observation. Obviously, we are hoping to develop technologies that allow us to look outwards as well towards space. Space situational awareness is obviously a big part of the national space agenda. With Earth-based as well as soon space-based platforms collecting vast amounts of imagery from near-Earth orbit, we will similarly require AI algorithms to process the imagery so that we can find out what went where in space. Basically to survey and characterize all the man-made objects, particularly space junk that are currently circulating the Earth.
Yeah, I think the work that AIML does is world-leading, and although I think it's very known in Australia, Microsoft presents this huge opportunity to be able to distribute that research to the world and have this truly global, sustained impact, and I think that's really exciting.
Yeah, and yes, the space sector in Australia is experiencing significant growth and getting a lot of attention. For homegrown science and technology to penetrate the international market, we do need to collaborate with international partners. And as Nick mentioned earlier, Microsoft presents us a valuable opportunity to do that.
TJ, it's been great to catch up. Look forward to working with you in the future.
Great to see you back in Adelaide, Nick, and we look forward to our partnership.